Good day, students. Welcome to math.serve.com. In this clip, we're going to be going over problems 21 to 24 of the August 2015 Algebra 1 Common Core New York Regents exam. All right, let's take a look at problem 21. It says, given the following quadratic functions, so we have a quadratic function in symbolic form or algebraic form, and we have a quadratic in numerical form in a table of values. So these two are two different functions of a quadratic nature that are being represented in different forms. Okay, so let's go ahead and see which of the following statements are true. So this right here, this is n of x, and this is g of x right here. Let's underline their names. So we have g of x right here, and this is n of x. Okay, so the first one, over the interval -1 to 1, the average rate of change of n of x is less than the average rate of change of g of x. So for this statement number 1, we are to find the average rate of change of both functions and see if the average rate of change of n is smaller than that of g. Okay, so just a real quick reminder, you want to recall that the average rate of change, average rate of change, I'm going to be calling this AROC, just to save time, over an interval is simply the slope of the line towards, through the 2 points. So y2 minus y1, your rise over your run, x2 minus x1. Given in function notation, let's say you're going from a to b, is f of b minus f of a divided by b minus a. Okay, so this is AROC from a to b. So let's use that for option 1 and see if option 1 is true or false. Let's start by computing the average rate of change of, let's do n first, okay? So average rate of change, I'm going to call it AROC, of the function n on the interval -1 to 1. This is my a and this is my b. Is simply going to be the rise, which is n of b, n of 1 minus that's the rise, n of 1 minus n of -1, divided by the run. Okay, rise over run. So you're going to go 1 minus -1. Okay, so just keep in mind that for n, this is a right here. Let me just indicate it so it's clear. This is a, and this is b. Okay, so we're doing n of b minus n of a divided by b minus a. Okay, so this is your rise over run. N of 1 is the output when x is equal to 1 on your table of values for n. So when n is 1, what's your output? When x is 1, n of 1 is 9. So we have 9 minus n of -1 is your output when x is equal to -1. So n of -1 is 5. All right, so we have 9 minus 5. This is your rise, change in y, okay, divided by the run. Minus times minus is plus, so you slash and dash. So you have 1 plus 1. Okay, 9 minus 5 is 4, divided by 1 plus 1, which is 2. And your final answer is 2. So the average rate of change for the quadratic n of x from -1 to 1 is 2. Now let's compare that with the average rate of change of the quadratic g on the same interval from -1 to 1. Now do you see how this is going to change? Instead of n's, you're going to be having g's here. So you're going to have g of 1 minus g of -1. This is a rise, y2 minus y1 over what? Over your run, okay? x2, which is 1, minus x1 is the same thing as b minus a, okay? All right, let me just put that notation there. So a1 can be thought of as x1 and b can be thought of as x2, whichever notation you like to use. All right, so here we also have that's the a, and that's the b right there. So let's go ahead and compute this. The difference between the symbolic notation And the numerical notation is that for the symbolic notation, we have to actually use the order of operations to compute the value of our outputs. But for the tabular notation, numerical representation of a quadratic, it has already been computed for us. So if we have an input present in the table, we can simply determine what the output is just by pairing them up, which is pretty easy. Okay, so let's go ahead and compute what the outputs are. G of 1, what does this mean? G of 1 simply means what is the output when you set x equal to 1 in this function right here. Okay, so let's put that to the side. G of x is negative x squared minus x plus 6. Okay, so G of 1, I'm going to plug it into this function, is going to be negative 1 squared minus 1 plus 6. Okay, now let's work this out. What is negative 1 squared? Is it positive 1 or is it negative 1? This square affects only the 1. How do we know? There isn't any parenthesis including this negative symbol with this 1 here that's being squared. So this square affects only the 1. So negative 1 squared, you can, if I want to group it to show you how I'm going to execute my simplification, these two go together. The negative is outside the influence of the square. Okay, so that yields negative 1 minus 1 plus 6. Okay, using order of operations, negative 1 minus 1 is negative 2 plus 6, and that gives us positive 4. Okay, so G of 1 is positive 4. Now, what do we do next? We want to find G of negative 1. Okay, so that's like your y1. So G of negative 1. Now you want to be really careful whenever you're evaluating a function at negative input values. Why is that? Because when you raise a negative number to an even power, sign changes do occur. Okay, and when you have a negative sign in front of an input, sign changes do occur too. So you have to be really careful here. So we're going to take advantage of parentheses for our protection. So we have minus x squared is negative 1 squared. Notice my use of parentheses here. Minus negative 1 plus 6. All right, so let's go ahead and simplify this, proceeding with caution. Now, negative 1 squared is negative, unlike the other one, is in the parentheses, which means that the square affects it. So that becomes negative 1. Here we have a minus times minus, slash and dash, this becomes a plus 1 plus 6. In this case, minus 1 plus 1 add up to 0, so we have 0 plus 6, which equals 6. So we have G of 1, 4, minus G of negative 1, which is 6. In the denominator, minus 1 minus 1 minus minus 1, minus times minus makes that a plus, so we have 1 plus 1. Okay, almost there, computing our average rate of change for G of x. So we have 4 minus 6, which is negative 2 over 2. Average rate of change is negative 1. So we can see from our calculations that the average rate of change of n is greater than the average rate of change for G. Okay, let's write that down. AROC for n, just on that interval though, you have to be careful, is greater than AROC for G on the same domain. Okay, so what does the statement say? It says n, the AROC of n is less. Is that true or false? That is false. Okay, all right, let's shift our attention to statement 2. Let's see if it's true or false. For statement 2, what are we looking at? It says the y-intercept of G is greater than the y-intercept of n. Okay, so how do we compute intercepts? if you want to find the intercept of a variable, you simply set the other variables equal to 0. Okay, so when you're looking for the x-intercept, you set y to 0. When you're looking for the y-intercept, you set x to 0. Okay, so let's write down a quick note. Recall, to find y-intercept, you do what? Sorry about that. You set the other variable. This is two-dimensional situation here, so we just have x and y. So to find the y-intercept, you set x to 0. And when you're looking for the x-intercept or roots, you set y to 0. Okay? Okay, so now let's go ahead and find the y-intercept of n and g and see which one is bigger. All right? So let's start by looking for the y-intercept of g of x. How do you compute that? The y-intercept of g of x is simply g of 0. What does this mean? Simply means you set x equal to 0 in g. Okay? G is the representation in algebraic form. Symbolic notation there, g of x equals negative x squared minus x plus 6. So to compute g of 0, simply input 0 for your x's. Okay, so we have negative 0 squared minus 0 plus 6, which is equal to 6. Another way to find the y-intercept of a quadratic function in standard form is by determining what your c value is. In this case, we can clearly see that c is equal to positive 6. Okay? All right, now let's find the y-intercept of the numerical function n of x, numerical quadratic. So to find that, how do we find the y-intercept here? It is the same procedure. You set x to 0. Okay, so what we'll do is we will go to our table of values and look for the output values for when x is equal to 0. When x is 0, we can clearly see that the output is what? 8. What does that mean? It means that the y-intercept is 8. Okay, so let's go ahead and write that down. The y-intercept of n of x is equal to 8. All right, so what's our conclusion? Y-intercept of g of x is less than the y-intercept of n of x. Okay, what does the statement number 2 say? Y-intercept of g is greater. This is false. Okay, so we're going to keep on going until we see a true statement or exhaust all the options but one. Let's advance to number 3. It says the function g of x has a greater maximum value than n of x. All right, let's go ahead and compute the maximum value for g first. So g of x is the algebraic representation. There are two ways you can find the maximum value. Actually, there are more. But if I want to compute this algebraically, I can complete the square, or I can use the formula to compute this numerically. Okay, I'm going to be using the formula here. G max is basically g evaluated at negative b over 2a. Okay, so that's how you compute the maximum of a quadratic. A is negative 1, b is negative 1, and c is 6. Okay, so g of negative b over 2a is simply g evaluated at negative. B is negative 1 over 2a, 2 times negative 1, which is the value of a. Okay, all right, let's go ahead and simplify that. All right, so what do we have here? Negative b over 2a, we have g of minus over minus is plus, so these two become a plus, so we have negative 1 over 2. Okay, g of negative 1/2 is what you get when you input 1/2 into the function. All right, so that's the function right there, g of x. So g of negative 1/2 is simply going to be negative quantity 1/2, actually negative 1/2 square minus negative 1/2 plus 6. Okay, let's simplify this. You have negative 1/4 because you squared the numerator and the denominator plus 1/2 plus 6. Okay, now let's combine these two. What is negative 1/4 plus 1/2? You can convert this into, find the LCD basically. So we have times what? What's the LCD of 4 and 2? The LCD is 4. So you times this by 2, top and bottom. This is a whole number. Let's leave that alone for now. So we have negative 1/4 plus 2/4 plus 6. So we have 6, negative 1/4 plus 2/4 is 1/4. So 6¼ is the maximum value for G. Now, how about N? What is N max? N max is simply the highest or the biggest output value, right? So if you take a look at the pattern from our table, we can discern what's the maximum output value is. So take a look at this table right here. The axis is basically the movement in the horizontal direction, and the N is the movement in the vertical direction. It goes from -7, increases, and goes right back to -7. That is the behavior of a negative quadratic function. So what is the highest value it attained before it started to go back down? That is the maximum value. So you see it's increasing, 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 increasing. What happens here? It starts to decrease. Okay? So let's indicate that. That's increase, 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 and then what starts to happen? It starts to decrease. All right, so what is the highest value it attained before it started to reverse direction? Answer is +9, so that is a maximum value for N. Okay, so N max from inspection of our table is 9. What does this tell us? Conclusion is that G max is what? 6¼ is less than N max, which is 9. Okay? What does the statement say? It says G max is greater than N. Is that what we got? We have G max is less. So that means statement number 3 is false. All right, so by elimination, we can clearly see that our answer is option number 4. So if you're taking the test, you can just conclude that this is your answer. But guess what? We're going to go ahead and show you that this is actually the correct answer. We're going to work out option number 4. All right, so for option 4, it says the sum of the roots of n of x equals 0 is greater than the sum of the roots of g of x equals 0. So the roots are basically the x values when y is equal to 0, your x-intercepts. So let's take a look at n first. When you're looking for the roots for n, you're looking for what are the x values when n of x or y is equal to 0. Okay, there are 2 of them here as you would expect for quadratic. At this point, we have an x-intercept. At this point also we have an x-intercept. So our roots are -2 and 4 for n of x. Those are our roots. Okay, so let's find the sum of the roots for n of x, and then we're going to compute the sum of the roots for g of x. Okay, so for option 4, which should be the true statement, the roots of n, the roots of the statement n of x equals 0 are, let's see, I already forgot what they are. What are they? -2 and 4. N equals -2 and n equals 4. So the sum of the roots are negative 2 plus 4, which is what? Positive 2. There you go. Now let's find the roots of g. Now it's not as easy as that of n. This one we have to do some algebraic manipulations here. Okay? So for the roots of g of x, we have to factor and use a zero product property to finish it up. So g of x equals negative x squared minus x plus 6. So let's see what we can do here. Set it equal to 0. And then we can use the x game to factor this. So x AC is negative 6. B is what? B is negative 1. So what's two numbers multiply to give you negative 6 and add to give you negative 1? Okay, before we do that, let's get rid of this minus here. That'll make it our work much easier before we do the x game. So anytime you have a negative in front of the square for the quadratic, you can multiply the entire equation by negative 1 so that it simplifies the problem solving process. So let's multiply the entire equation by negative 1. So what's going to happen is that all the signs are going to flip. So we're going to have x squared plus x minus 6 equals 0. That looks much better. So let's make our x game. Factorization. AC is negative 6 and b is 1. The two numbers that work are negative 2 and 3, because when you multiply these two numbers, you get negative 6. When you add them, you get 1. Okay, so we have x minus 2 times x plus 3 equals 0. All right, so now we're going to use the zero product property and set both of them equal to 0. And then you see that the first root is, you add 2 to both sides, add 2. First root is 2, and the second root, you subtract 3 from both sides, and you have x equals negative 3. Okay? All right, so there goes the roots of g. Okay? So roots of g are x equals 2 and x equals negative 3. So the sum of the roots is what? It's going to be negative 2, positive 2 minus plus negative 3, right? So if you simplify this, this is 2 minus 3, which is negative 1. So what does this tell us? It tells us that the sum of the roots of what's the first one? N is what? Sum of the roots of n is 2, which is greater than the sum of the roots of g. Okay, so what does the statement say? Sum of the roots of n is greater than sum of the roots of g. Perfect. That's exactly what we anticipated to occur. Okay, so you don't have to do all the work. If you get these first three as false, by elimination, you know that option number 4 is the correct one. But I just wanted to show you how to do the process of finding roots, so that just in case this were option number 1, you will be able to do it and get a good score on the problem. All right, let's take a look at problem 22. It says, for which value of p and w is p plus w a rational number? So you want to recall an important point, which is that in order to get a rational sum, the addends have to be rational. So rational plus rational equals rational. That's how it always is, okay? All right, so let's look at this case here. What this is telling us is that we have an option here where both numbers are rational. Rational numbers cannot be expressed with radicals in its simplified state. So if a rational number is simplified completely, there are no radicals there. There are no infinite non-repeating decimal representation there. No i's or anything like that. That looks funny. Okay, so let's look at these options and see which of them can we simplify to eliminate that radical piece. Radicals are associated with irrational numbers. Okay, so how do you know that you can eliminate the radical? The radicand is what's underneath the square root symbol. The radicands, you look at all of them, whichever one have perfect squares for both, not just one, those two numbers are rational. So do you see any perfect squares in all the radicands here? Oh, we have option 2, that's perfect. That's exactly what we're looking for. Why is that the case? Because check this out. 1 over root 4 plus 1 over root 9 can be simplified into 1 over square root of 4 is 2, plus 1 over square root of 9 is 3. 1/2 and 1/3 are rational because they are the quotient of two integers. Okay, so these are rationals, and you can find the sum. Let's go ahead and find the sum real quick just to show you that is correct. Find the LCD by multiplying by 2 and 3 there, because the LCD of 2 and 3 is 6. So we have 3 over 6 plus 2 over 6. And the answer is 5 over 6. That is your sum. And what kind of number is this? 5 over 6 is rational because it is the quotient or the division of two integers. All right, so our answer is option number 2. All right, let's take a look at number 23. It says the solution of the equation x plus 3 quantity square equals 7 is. So this is a quadratic that's been solved by completing the square. The square is already completed, so we just want to isolate the x. Okay, so there are 2 steps we're going to use here. Firstly, we'll use the square root property to eliminate this square, and then we'll just subtract to get x isolated. All right, using the addition property of equality. So first thing we'll do is take the square root of both sides, because the opposite of square is square root. Now we have x plus 3. Do not forget this. This is extremely important. Whenever you're taking the square root of a square, don't forget to insert plus or minus on one side of the equation, either on the left or on the right. It doesn't matter. Since I'm solving for x here, I'd rather have it on the right side so I don't have to deal with it anymore. Let's not forget our square root there. Okay, so there you go. Applying the square root property helps us eliminate the square there. So we have the square root on the right side along with a plus or minus. To finish this off, you simply subtract 3 from both sides. Okay, don't forget you're going to subtract 3, okay? So you're going to have -3 plus or minus root 7. Answer is option number 3. Okay, let's take a look at the last multiple choice problem in this installment. So it says, which trinomial, problem disappeared. Which trinomial is equivalent to 3 times the quantity x minus 2 squared minus 2 times the quantity x minus 1? So the best way to approach this problem is to just expand this expression completely, get rid of the parentheses, and see which of this option it matches, okay? So let's go ahead and expand this. We have x minus 2 squared. What does that mean? Now, this is a mistake most students make. They see x minus 2 squared, and they distribute the square there. Okay, and then they get x squared minus 4. This is wrong, okay? When you have x minus 2 squared, that means that you have to multiply that quantity by itself. You have 2 copies, okay? So this is how you do it. Now, here you have -2. Anytime you have a negative in front of a parenthesis, you want to be careful because that negativity causes signs to flip. So we're going to distribute -2 as a package across x and -1. Okay? So we're going to get -2x. Guess what? This becomes +2. You got to be careful with that, with the signs. Now, x minus 2 times x minus 2, let's multiply that using the box method. Let's put that on the side here. Oh, it's still on the right side. You can multiply it any way you like. It doesn't really matter how you do it. I like the box method because my students hardly ever make mistakes when they use the box method. They always get it right. So we want to play it safe here. So we have x minus 2 and x minus 2. So this is like a multiplication chart. That's what it is. Okay, x times x is x squared. X times -2 is -2x. X times -2 is -2x. -2 times -2, minus times minus is plus. 2 times 2 is 4. If you notice, the diagonals are like terms which can be combined. Okay, so our product is going to be, bring down the 3, times x squared. What is -2x minus 2x? -2x minus 2x is -4x. Okay, so we have -4x minus 2 times minus 2 is plus 4 minus 2x plus 2. Now let's go ahead and distribute this 3 across all the terms in the parentheses. Okay, that's what the distributive property is all about. You have to be fair. So we have 3x squared minus 12x plus 12 minus 2x plus 2. Now combining like terms, we have 3x squared. There are no other squares there. Okay, now let's go shift our attention to the first degree terms. -12x minus 2x. The signs are the same, so you add and keep the sign, -14x. And then we have the 0 degree terms, the constants, plus 12 plus 2. Plus 12 plus 2, add and keep the sign, +14. So there goes the expanded form of this expression right here. Answer 3x squared minus 14x plus 14, option number 4. Thank you so much for taking the time to watch this presentation. We appreciate it. If you found the contents of this tutorial beneficial to you, do give us a thumbs up. We appreciate the positive feedback. And do share it with your friends via Facebook, Twitter, or any social networking program you use. Do not forget to subscribe for the remainder of this review series. If you have any questions or need free support, just post your questions in the comment section below, and we'll be glad to support you as soon as possible. More clips can be found on math.serve.com. Thanks again for watching, and have a wonderful day.